Okay, so today's lesson is 5-5, proportional and non-proportional relationships. So what we are doing today is determining if something is proportional or not. So how we do that, if we look at this first example, says determine whether the cost of coffee is proportional to the number of pounds. If the relationship is proportional, identify the constant of proportionality and explain your reasoning. So I first want to talk about some words in this. So constant of proportionality, we'll just call that our constant, because if it's constant, it is proportional. So it's kind of a silly term to me that it's so long. But the constant means a number that you're going to get no matter how many you have of something. It would be the same number that you would use each time. So how we determine that is we always set it up y over x. So on your paper, I want you to put, I guess I should have moved this over, but I want you to put your constant equals y over x. Okay, sorry, I'm having to write with one finger. So your constant equals y over x. It's always set up that way. That's how we determine it. So anytime they give us a table, so this table's up and down, your x is always the first variable or column, and your y is the second. I'm going to fix that y. So it's always set up x, then y. So this one we have coffee in pounds here and the cost here. So also when they say determine whether the cost is proportional to the pounds, they're telling you cost first, which is your y, over pounds, which is x. So we would do that. We would do 3 over 1, and then you simplify it. That's already simplified. And what I mean by simplify is just see if there's anything you can divide out of both of them. So then we would have 6 over 2 next. And if you notice, those are both even. So we can divide them both by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. We get 3 over 1. The next one would be 9 over 3. We can divide those both by 3. When we do that, we get 3 over 1. And the last one, 12 and 4. 12 over 4, you can divide those both by 4, and you get 3 over 1. So now, when you see a pattern, and what I mean by pattern is if you see the same number over and over, or you're constantly getting the same number and over, that means it is proportional. Because our constant is what you get over and over again. So on this one, we got a constant of 3 over 1, which when you simplify that, that is just 3. So we got a constant of 3 because, yes, it's proportional. All that means is it's basically $3 for every pound of coffee, which should make sense because you want a set constant for that. Just like if you go to the grocery store and I'm making up this price because I have no clue how much oranges are because I hardly ever buy them. But let's say that oranges are, we'll make it easy, $1 per pound. Well, that would mean if you're buying 5 pounds of oranges, it would be $5. You're not going to be charged differently because you're buying more or less. That wouldn't make sense. So that is your constant. So we get this number over and over again, which means yes, it's proportional. And then the number you got over and over again is your constant. So what I want you to do, I want you to try this number 1 down here. When the table is written sideways like this, we've talked about this before, x is always the one that's on top, y is on bottom. Okay, so you'll pause the video and try this, and then press play and I'll go over it. Real quick though, when it says explain your reasoning, when you're showing me it written out like this, that is your reasoning. You're showing me what your constant is, or you're showing me that they're not proportional. So don't think too much into that part. Okay, so attempt number 1, and then I'll go over it. Okay, number 1 tells us determine whether the number of legs are proportional to the number of spiders. If the relationship is proportional, identify the constant of proportionality and explain your reasoning. Okay, so first of all, they told us legs to spiders. So they're telling us the order. They're telling us legs over spiders, okay? And when we're setting that up, it's always set up y over x. That's what that means. Our constant is always y over x. Now, in the tables, if they're sideways like this, they always give you x on top and y on bottom. Okay, if they're up and down, we know this from the past. X is always in the first column, y is in the second. So we always set it at y over x to see if it's proportional. So this means I have 8 over 1, which is 8, 16 over 2, which also equals 8, 16 divided by 2, 24 over 3 equals 8, and the last one, 32 over 4 equals 8. Now you go back and look, did they all come out to the same thing? Yes, so this one is proportional. So this means our constant is 8. And on Explain Your Reasoning, you've done it when you show me all of this. Okay, you're telling me, okay, because when you divide them all or set up your proportions, they all come out to the same constant over and over again that's repeating. So therefore, it's a constant. You're constantly getting 8 over and over again. That's what that means. Okay, let's look at example 2. So this next example, we're just doing more of the same type of problem. It says, determine whether the distance is proportional to the time traveled. So remember, they will always tell you how to set it up. Distance to time. So we will have distance, I'm just going to put D for distance, over time. Okay, so when we have the table like this, we also know X is first. I don't know why that quit writing. And then it's your Y. So Y over X, distance over time. So if it's proportional, identify the constant and explain your reasoning. Again, if you just show your steps, that is expressing your reasoning. So we have 50 over 1, which when it's over 1 is already simplified. 50 over 1. Then we have 70 over 2. Those are both even, so you can divide them by 2, and you get 35 over 1. And then the last one, 90 over 3. We can divide those both by 3 to get 30 over 1. So if you notice, these are not the same. So it is not proportional. Your distance is not proportional to your time, so there is no constant because there was not a number that we're getting constantly over and over again. So what this means is that your y over x, that may be like, this is a speed limit. So say your parents are driving you down the road. This just means that they're driving at different speed limits over the 3 hours. They're not driving the same speed. For example, if they were driving 50 miles per hour, the whole time, these would have all come out to 50 over 1. But since they're different, who knows, this could be like a school zone. They were going 50 miles an hour the first hour. The second hour, they were driving 35 miles an hour. The third hour, they were driving 30 miles an hour. Or it could be split as far as going faster because, 50 and then only 20 and then only 30 more. Yeah, so they were driving slower. So it just means that maybe they weren't driving the same speed the whole time. So you do not have a constant. So I want you to try number 2, but you won't get to see me go over. Actually, I'll just check it here. Pause your video, try it, and then I'll explain it here. Okay, so determine whether the number of ice cubes is proportional to the number of drinks. If the relationship is proportional, identify your constant and explain your reasoning. So remember, when they're written like this, your x is first, then y. They also tell you, because they're always going to tell you y over x. So they said ice cubes to drinks. So y over x. So we have 6 over 1. That equals 6 over 1. Then we have 14 over 2. So if I divide 14 by 2, that's 7 over 1. Then 22 over 3. That doesn't simplify. That just stays 22 over 3. Or if you were to divide it, that would come out to 7 point something. So if you notice, we're getting different numbers. So the answer to that one is not proportional. Okay, it's not proportional. There's no constant because we got different numbers over and over again, and this explains your reasoning. So that just means it was probably random on them scooping ice cubes into a drink. They didn't make sure each drink had exactly the same amount of ice cubes. Okay, let's look at example 3. Let me see if I can scroll down. Nope. So example 3, it says a circle's circumference is proportional to its diameter. So now they're not asking if it's proportional. It's already telling me it is proportional. So we know that there's a constant. It says use this figure to find the constant of proportionality. So we're going to use this image to find the constant. Then write an equation relating the circumference of the circle to its diameter. So we're going to use that constant to set up an equation. Then it asks, what is the circumference of a circle with a 6-inch diameter? So this asks me two things. So first, since we know it's proportional, they tell me its circumference is proportional to its diameter. So remember, they will always tell you y first, then x. So they said circumference over diameter. So I take that from this figure. The circumference, C, says let C be the circumference, is 12.56 over the diameter. Diameter is what goes all the way across a circle. Radius just goes halfway across. So they gave me a diameter of 4. So if we do 12.56 divided by 4, we get 3.14, which should maybe look a little familiar because that is the number we use for pi. Okay, so it tells me to write an equation relating the circumference to the diameter. So we know when we divided them, we got 3.14. So that meant if I worked backwards, if I did 3.14 times the diameter 4, it would equal 12.56. So it says let C be your circumference and D be the diameter. The circumference of a circle is about 3.14 times the diameter. That just means this number, it's about 3.14 times bigger, which times means you multiply. So 3.14 times 4 equals 12.56. So C, 12.56 equaled 3.14 times the diameter, which was 4. So here is my equation. Or you've probably seen it before, just written like this. Pi d. C equals pi d, because that is the formula for the circumference of a circle. But anyways, here's my formula, or my equation. C equals 3.14 d. So now I'm going to go back and answer the other question. What is the circumference of a circle with a 6-inch diameter? So we take 6 and plug it in for the diameter. So 3.14 times the diameter. So we would do 3.14 times 6. When we do that, we get 18.84. So if the diameter had been 6 instead of 4, the circumference would be 18.84. Because we know it's proportional. That means no matter what, every time you're going to have 3.14 times it, because that's your constant that you would get over and over again, like on the previous problems. So this is going to be a shorter lesson because I'm not going to make you do this next problem because I don't like the fractions that they used. It's too complicated. So we will stop here.